Assalamu alaikum wa rahmatullah. Today we will cover Unit 4, More Concepts, Models. The recording today will be relatively short because we have covered the conceptual models in block or Unit 3. So today and Unit 4 will be only practicing what we have learned, and we will add few more concepts to the ones we covered last lecture. In Unit 3, you learned and practiced the conceptual model. You learned how to identify conceptual classes, categorize real-life and real-world entities, and representing them with using classes, representing the relationships between them. And at the end of Chapter 3 or Unit 3, we generated the initial structure, including the conceptual classes with their attributes, their associations, and related invariants. In this unit, another system is discussed to give students the opportunity to practice more on what we have learned in Unit 3. A few more techniques and concepts will be covered, and the systems we are using today are the shopping system and another smaller system, the training system. As we have done in Unit 3, we start with the system domain for the shopping system. And as you can see, this is the written system domain for the system we are covering. As usual, we will use this system domain and the following use cases to identify the classes, identify the attributes, and identify the relations between them. To remind you what we do to identify classes, we underline all nouns and noun phrases in the system domain and in the use cases, and then we apply on this set of candidate classes the textual analysis. The textual analysis will help us identifying the relevant classes from the irrelevant classes. We also read the system domain and the use case classes to identify the attributes of the classes identified in the first phase. We also try to recognize the relationships between classes from this system domain. We have practiced that in Unit 3. You need now to try yourself and find out whether you can apply what we have learned in Unit 3 on the shopping system. To cross-check your work with the solution, you can find the solution in the unit and find out whether you have done the textual analysis correctly, whether you have identified the relevant classes, whether you have identified the right attributes and the right relationships between the classes. You should more or less identify this list of candidate classes. As you know, they are not all relevant classes. For some reason or another, we're going to reject some of these classes. more or longest list of classes is here. For example, if you look at the candidate class customer name and customer address, clearly, as we have learned from the guidelines of rejecting irrelevant classes in Unit 3, the customer name is the name of the customer, and that's an attribute for the customer. But the customer itself as a noun is a good candidate for a class. This is something that we have done before. You need to practice it and to check your answer against the ideal answer given in the unit. In this slide, small issue is discussed of how to distinguish between the order price of the item and the product original price for that item. In the requirements, it says that from time to time, the order item price can change. In this case, you may sell the item with two different prices at two different times. And that's represented in the object diagram given here. You find that order item 3 the product 36 is sold for 6.5, where in other order items it sells for 6.99. Now we have the long list of candidate classes, and in Unit 3 we introduced you to the guidelines of rejecting irrelevant classes, and here they are. We look at the list of candidate classes and answer the question whether it is a property. If it's a property, then we reject it, and we move to the next question. Does it refer to a behavior of the system? Then it's not a good candidate class in our system. If the noun or noun phrase is outside the scope of the system, then we reject it, as we have done before in Unit 3. If it refers to an aspect of the interface, it will not be a good candidate class. If it's a connection between significant entities, then it is an association, not a class. But in some situations, this particular point, if it is a connection between two classes, and this connection needs extra information, as we mentioned in Unit 3, we will build a class so we can hold the data and save the data that need for this connection. If the noun and noun phrase is just talking about the system in general, describing the different aspects of the system, then, as we mentioned earlier also, it is not a candidate class. It's not a good candidate class. If it's only a language item, then it will not be also a candidate class. Now, after you apply the guidelines of rejecting irrelevant classes, you can compare your work with the answer given in this slide and see why you may reject or retain a class. For example, company is rejected because it's outside the scope of the system. Product is a very important class in the shopping system, so it retains. We reject website because outside the scope of the system. We reject time, language item, and so on. We return customer, order item, session, product, but we reject product A, product B, and so on. We continue with the list of rejection and accepting the classes, and in front of each one of them you can find the reason why it's rejected or why it is accepted. You don't look at this list only after you build your own list and see whether you got the right answer for deciding what are the relevant classes and what are the irrelevant classes in the system. In the exam, you may be given a system domain for a small system, and the question may ask you to identify the classes in that system. And in that case, you have to perform a textual analysis for that system domain given. You need to identify the candidate classes, and you find what are the relevant classes and what are the irrelevant classes. This can be a very good question in the exam. Further, after you identify the relevant classes, and in the shopping system, we found out that customer, registration, session, order, order item, product are our candidate classes. Maybe you find that customer is repeated, or the first one is actually not customer registration as one class. So customer registration is a class, session is a class, customer is a class, order item, and product. Out of all the long list of identified classes, we have only 1, 2, 3, 4, 5, 6 classes. Next, after we identify the classes, and that's what we have practiced in the previous unit, you need to categorize the classes. Okay. And we remind you that we have 5 categories for our classes: tangible classes or tangible entities, roles played by people, events, happenings, something related to organization, we call them organization units, or not tangible things, which are abstract entities. Now the 5 classes for the shopping system are identified as follows. Customer registration is an event, customer is a role, session is an event, order is an abstract entity, order item, abstract entity, product, abstract entity. You may argue that product is something tangible that I can't touch. Yes, in the real life, product is a tangible entity, but in the system, it will be represented by some abstract entity. Now, talking about the event candidate classes identified earlier, we mentioned in Unit 3 that you don't always represent the event as a class. There are some conditions that at least the event should achieve one of them to be able to consider it as a class, which are the event has properties or property of its own, then it must be represented as a class. If the event is connecting two significant entities in the system, then we may model it as a class. Or if the event occurrence need to be recorded, then some information about this event should be recorded in the system, and that won't be possible only by having the event as a class. We have two events here, the customer registration and the session. If you look at the session, we find that the session satisfies some of the conditions to be represented as a class and modeled as a class, which is it has a property of its own, starting time, of an event where the customer registration doesn't fulfill any of the conditions above, so we cannot represent it as customer as a class. We need to reject the event customer registration. After filtering this to events and find out which one is to be represented by a class, we may have the following classes: session, customer order, order item, and product. So out of the two events, session is now a class in the system where customer registration is rejected. As usual, for all the classes identified, we need to identify their attributes, the ones that we can identify from the textual analysis through the studying the system domain and the case studies. Then every class identified need to be described, and we call it class description, and that's part of the conceptual model. So in this slide you find the class description for the classes session, customer, order, order item, and product. Now we need to connect classes to each other to build our conceptual model. As you remember in Unit 3, these connections and links will allow the classes to cooperate, to exchange messages, and through these messages they can cooperate. If you go back to your system domain for the shopping system, you will find that textual analysis for the system domain will help you identifying important relations between classes. Like for example, you find the relation is for between customer and session, has between customer and order, is in between order item and order, is of between order item and product, and so on. After identifying the relationships between the classes, we need to add the multiplicity. Multiplicities are ways to show how many objects from this side of the link connected to how many objects from the other side of the link. So you have classes A and B. You need to decide how many objects of A can cooperate or linked to how many objects of the class B. And we have learned how to express that in Unit 3. Just as example, you can find multiplicities of 0 to 1 and 0 to many. Means in this diagram you have 0 or many students, means 0 or 1, 2, 3, 4 to infinity number of students can console a counselor, or they may not find a counselor because you have the choice of 0 and 1. We have expressed our thoughts about multiplicities in details in Unit 3. If you are not sure about what do you mean by multiplicities, how to apply them, please go back to Unit 3 for more information. More on multiplicities and how the multiplicity in this relation is implemented in real life by giving object diagrams for that relation. More details on associations and multiplicities for shopping system. Is for relation and how we used it, and where, has, is in, is of, Please go through this in details. We have covered that more than once before, and we assume at this level you will be able to understand how these associations and multiplicities are decided. Now, after applying what we have learned on identifying candidate classes, identifying their relations, and the relation between the identified classes, identifying the associations and association names, and also deciding about the multiplicities, we will have this diagram representing the conceptual model for shopping system. If you want to read it, we say that a session is for a customer 0 or 1 session for all customers, where one customer has the chance to make 0 or more orders. He can make no orders, or 1 order, or 2 or 3 or 4, no limit for how many orders they can make as customers. Now, an order item will appear in an order, and an order may have no items, or it may have many items, means 1, 2, 3, 4, 5, and no limitation for the number of the item. Same for the product. One product may appear in more than one order item or made order item. Today we are learning a new term related to associations, which is recursive associations. To explain this important term, we consider the case that a product in the shopping system may be considered as alternative for another product. Means you want to get a product and you cannot find that product, you may be advised to take an alternative product to replace it. In this situation, the relationship between the objects of the same class is there. Means I want to relate a product to a product. So far, we relate objects from 2 different classes using association. But this is the first time that we come across a case where we need to relate 2 objects of the same class. This association, where we link objects belonging to the same class, is called a recursive association. You can see the figure below showing a relation between a product and another product object. So you find the association is coming out from the class product and going back to the same class. Here, an object diagram showing how the recursive association will be implemented at the object diagram level. You found that product 3 and product 10 are alternative to each other, so as product 4 and product 36. Now, to complete the association, we gave it a name, is alternative 4, but also we need to decide about the multiplicity. So one product can be alternative for another product, so it's a kind of 1-to-1, or it may not find alternative product. So you may have an alternative product for one product, or you may not have any alternative product. So the multiplicity will be either 0 when I cannot find alternative for my product, or 1 when there is alternative for my product. And that's how we draw the link with its multiplicity. In the case of product, we are linking one object to another. But recursive association is not only for this case, it may link one object to many objects, as we are going to see in the next slide. In this slide, we know that some nurses supervise other nurses. A nurse is supervised by at most one other nurse. In this object diagram, we find that nurse 1 is supervising nurse 2 and 3. Nurse 2 is supervising nurse 4 and 5. Nurse 3 is supervising nurse 6, 7, and nurse 8. So the relations existing between these objects is recursive association relations or recursive links, because they are all nurses of the same class nurse. So we are representing links and relations between objects of the same class. How this can be represented? The same, but the multiplicity will be different. If you look at the class diagram here, you find that 0 or 1 nurse will supervise 0 or many nurses. And to read the association correctly and the link correctly, you find an arrow in front of supervises. So it means you read it from this side to this side. 0 or more nurse supervises 0 or many nurse. So when you have one nurse, it may supervise 1, 2, 3, 4, or no nurses. Okay, or you can find a nurse that is not a supervisor for any other nurse, a very junior nurse. So this is how we represent the association and the links when we are relating objects of the same class. Now we complete the conceptual class or class diagram for the shopping system by adding the recursive relation to the product class, as you can see in this diagram. To complete our conceptual model, besides the class diagram and the class descriptions, we need to identify our invariants. To remind you, with the definition of invariance, it's a condition on the elements of the conceptual model that must be always hold and which follow from a real-world constraints. Some of the invariants can be very simple. They can be part or can be specified in the class description. Like, for example, if I want the customer number to be unique, I can express that in the class description. As you can see in this slide, I'm saying customer number, the unique number of the customer. Not all invariants are that simple. Some invariants are more complicated. Consider this constraint. A customer may have no more than one unsubmitted order. This is something that I cannot express in the class description. I need to make it very clear. And I raise the following invariant based on this real-world invariant. I write the constraint: a customer may have no more than one submitted order as the following invariant. Customer object may be linked to no more than one order object whose status attribute has the value unsubmitted. In the second relatively complicated invariant, if a customer has unsubmitted order, then they must also have a session. This can be written as invariant as: if a customer object is linked to an order object whose status attribute has the value unsubmitted, then the customer object is also linked to a session object. We continue to identify more constraints. 3 of them are given here. You can study them and train yourself of how you can convert the real-life constraint to an invariant. This also can be part of the exam, that you are given a constraint and you are asked to write it as an invariant. Or you may not be given the constraint, you are given the system domain, and you need to identify the constraint and write it down as invariant. So the 2 examples in this slide and the 3 examples in this slide can be helpful to teach you, hoping that you learn how to write an invariant. Now we need to decide about whether we have derived attributes and associations. Again, this have been covered in Unit 3, and in Unit 3 we make it very clear that an attribute of a class is described as derived if for every object of that class the object's attribute value can be deduced from other aspects of the model. And that's what we have done with the age attribute. We deduced it from the date of birth. Same, we may have some derived associations which is described as if all of its links can be deduced from other aspects of the model, then we can deduce a derived association. Here you find that the total cost value for the order is a derived attribute because you get it from calculating and adding all the order items in that order. So after you decide the items for the the price for the individual items in the order, the sum of all the sum of the individual prices of the order items will give you the total cost, and that's a derived attribute. We are done now with building the shopping system conceptual model. Our class diagram in this slide is ready. Our descriptions for all classes is also there, and at the end we have the 5 invariants that we have identified. So we are now done with building the conceptual model for the shopping system. To remind you that you must be ready and good in developing conceptual model, because we have covered that in details with examples, with descriptions for 2 big systems, the hospital system and the shopping system. Before that, we applied it in a simple system, the DVD library. So now you have 3 examples with details and diagrams, descriptions, invariants for 3 different systems. If you are in doubt about any of the things that we have covered, please go back to Unit 3 and Unit 4 we are in now and review how a conceptual model is to be built, what are the parts of the conceptual model, how to identify classes, identify their attributes, identify their relations, and decide about the multiplicities, and then build the class diagram, describe the classes in details, and identify the invariants. Also, in Unit 4, there's a 4th system. It is smaller than the shopping system and the hospital system, but also it is helpful to study that particular system, which is a training system in session 3, and deepen your understanding for this very important part of software development. Thank you very much. Wassalamu alaikum wa rahmatullah wa barakatuh.